So hello there. So this video will be talking about and working with the ATMEGA328P. So basically the microcontroller in the Arduino Uno. So there are a couple of things that I want to discuss first. So basically the Arduino Uno is technically not a microcontroller. It is actually based with this microcontroller right here, the ATMEGA328P. So the Arduino itself, or the board itself, just basically a development board so that users can easily insert some pins in this here, because it has a pin headers, and you don't have to worry with the power regulation because it has a IC circuits right here, power regulator ICs, so you don't have to worry if it with the like let's say you want to power 9 volts or 12 volts power. So it has a like step down power regulation right in here, and different onboard LEDs, just yeah just for indicator of the let's say the asynchronous transmission, the TXRX, or serial communication, and also the indication indicator, and some um, reset on buttons right here. So yeah, the Arduino Uno makes it simple for you to use it. Use this microcontroller right here, the ATmega328P, and also to communicate to your computer because it has a USB communication and port as well. So there are a couple of things why we want to just scrap out all of those things and just use this microcontroller right here, because I mean, this is the brain of it, the brain of this Arduino. So you just want this for a couple of reasons, like maybe you're working with a battery powered project, and you want to run it for like weeks or even months. Um, Using this Arduino Uno board right here is not necessarily the efficient solution, mainly because again of this external ICs that can play a role in the overall power consumption of this board. Like the onboard LEDs itself is like every LED right here can consume like up to 20 milliamps, and yeah, there are a lot of LEDs, onboard LEDs right here, and also the power regulation. If you are like you are not concerned with the power, like you are confident that you have a power constant power supply. So yeah, power regulators right here is not that useful for you anymore. So yeah, so if you are working with a again a low powered battery powered application, you just want to use this microcontroller right here, and we'll be talking about that, the ATmega 328P. So I have actually right here I don't know if you can see name. So this is the brain of the Arduino, and we'll be only working this one. And of course there are a lot of things that is also needed. I mean, not as much with this Arduino board right here, like the other LEDs, the power regulator. So yeah, mainly the only thing that we need for this one is a crystal oscillator with a couple of capacitors, and of course yeah, that is, I guess you only need that one, the crystal, because and in any microcontroller we need a clock pulse, or yeah, we need a system clock. So with an oscillator we can do that. And if you don't have a crystal oscillator in you, um, the the Atmega 328P has actually a built-in um, 8 megahertz of clock oscillator. So the later part of this video will also be doing that without the external oscillator, and just use the built-in oscillator. So let's get to work. So now let's work on with prerequisites. Okay, so as I've already mentioned, you'll be needing the ATMEGA328P IC, or yeah, microcontroller. And yeah, unfortunately we do need an external crystal, um, a 16 megahertz if you want to work it the same with the Arduino Uno's speed, because the Arduino Uno has a built-in 16 megahertz crystal right here. So yeah, like just like any microcontroller, a microcontroller need a system clock or a clock pulse. So a crystal oscillator will be uh, the component for that one, and a couple of capacitors, and capacitors just to filter out the, yeah, we just want a clean clock signal. So these are the job, the capacitors. The one I have right here is a 22 picofarad capacitor. So you'll be needing two of those. So again, if you don't have like a crystal oscillator lying around in your area, or your, yeah, you don't have one, we can resort to using the 8 megahertz crystal oscillator. But that means you are running twice or half the speed of a regular Arduino Uno, a regular, yeah, Arduino. So if you can yeah, compensate with that one, yeah, you can work on that. I'll show it later. But if you just want to really have the speed of a Arduino Uno right here, you'll be needing a 16 megahertz crystal oscillator and some capacitors. So, and another prerequisite or requirement is also an extra Arduino Uno, or if you have an AVR programmer, much better. So I don't have that. I don't have a AVR programmer, so I'll be using an extra Arduino Uno. And so yeah, just to act it as a programmer of our microcontroller right here. Um, yeah, you'll be needing an extra one. And I don't know if you know, but maybe if you have like two Arduino Uno lying around, you can actually just use or just pry this one. These are designed to, yeah, so that you can extract and get this microcontroller, because they are just inserted into a IC socket. So yeah, and again, the role of this extra Arduino is to act as a programmer of our ATMEGA328P right here. So make sure you have one, because yeah, any microcontroller needs a programmer to really so that you can program a code, or manipulate some bits or registers in the microcontroller. So let's work on with the connections. Actually, I forgot, you'll be needing like these extra components, because they are not really necessary. I've tried, yeah, for the power signals. You want if you want to a power an external a microcontroller, you from a external power source, you want a clean and yeah, basically a clean, and to avoid like ripples and such power source, you need some decoupling capacitors. So these, I have one right here, has a capacitance of 0.1 microfarad. So get two of those, because one is for the digital power, and I don't know if you might know this, but there's an actual power, a different, or yeah, isolated power source for the ADC. So one for the ADC and another one for the digital um, signal. So this is why we need two of them. And you'll be needing a 10 kilo ohm or 5k to 10 kilo ohm resistor for the reset right there. I'll be talking about that later. Just prepare these if you have maybe just this 10 kilo ohm resistor, because I've tried not using decoupling capacitors. it works well with the ATMEGA 328P. It's just that for long term, or if you really want to make it an efficient bare bone Arduino right here, uh, yeah, just spare some extra capacitors right there for our power signal. So yeah, again, some so overall we'll be needing a 10 kilo ohm resistor, a 16 megahertz crystal oscillator, and some 22 picofarad capacitor for the oscillation, and some decoupling capacitors for our power signals, a zero point 0.1 microfarad capacitance. So now let's begin the connection. And again, I forgot another component, but this is not necessary. This is the L7805 5 volts regulator. So if you have a let's say a 12 volts, or yeah, a higher than the 5 volts power, you might be needing this power regulator right here, just to have a 5 volts power signal, because again the my Atmega 328P is working on a 5 volts power source and logic. So again, if you don't have a 5 volts power source lying around, better use a power regulator. And yeah, and also I'll be using a 18650 battery right here. This will be the power source of my Atmega 328P, and as you can see, it has a uh, battery shield. So this does the job for me for regulating it to 5 volts. I don't know if you can see, but it has a 3 volts power line and also a 5 volts power line right here. So I've just soldered some jumper wires so that we can easily connect into the breadboard. So those are the couple of things that you might want to use. We're almost done, but the other component that needs to be connected is a pull-up resistor right here. So this pull-up resistor is to be connected in the first pin in the left side. This is the reset pin of the Atmega 328P, and it is active low, so we don't want to accidentally reset it, so we better connect it to high using a pull-up resistor. And so yeah, that's it. This is the bare bone Arduino Uno really. These are the components that you just need. And yeah, let's head on to the programming, and so that we can burn some bootloader. So if you have you have bought a standalone Atmega 328 chip, not in the found in the Arduino Uno, these actually come with no bootloader. So later on we'll program the Arduino right here to burn a bootloader in this Atmega 328P, and we could hopefully we could also upload some programs in this one. So yeah, now that we have proper connections in our Atmega 328P, it's time um, to interface it with the Arduino Uno so that we can program this Atmega 328P chip. So before we do that, let's head on and open first your Arduino IDE, and yeah, let's meet there. So again, open up your Arduino IDE. So this is the Arduino ISP sketch. So it can be found here. It is already included in the Arduino libraries. So head on to examples, then go on to Arduino ISP and click this sketch. So again, this is the sketch already provided by us from the Arduino team. So yeah, makes things much easier. So basically, if we want to make our Arduino Uno as a programmer to an Atmega chip, we want to upload this code to our Arduino. But first things first, you can't you can't program your Atmega 328 chip without burning it with a bootloader. So if you are the same with mine, which is a standalone ATMEGA 328P, which is the one that I have is actually again a standalone. It's not from a Arduino existing Arduino Uno, or I didn't pair it with my another Arduino Uno. It doesn't come with a bootloader. So first you need to burn it with a bootloader. So basically, bootloader is something that is a part of a section in the program memory of the ATmega 328P that uh, communicates with the with serial communication. So in this case, in order for we to make act our Arduino Uno as a programmer, we want to connect it with the ATmega 328P using SPI communications, or serial peripheral interface communication. And yeah, I will show the connections later on. But first, again, you need to set things first here. First, you need to select the board. Again, I'm using Arduino Uno. And then uh, we want to select here the programmer as Arduino as ISP. So select this one if you want to add Arduino as a programmer. Then after that, you need to click Burn Bootloader. So first, before we do that, I forgot. Don't click this one yet. Let's first um establish some connection from Arduino to the ATmega 328P. So just prepare in this sketch, and again select the programmer Arduino as ISP. Arduino Uno to the ATmega 320p, and don't worry, I'll be again showing the a schematic diagram and connecting the Arduino Uno as a programmer to the ATmega 328p. So first things first, connect. We want to supply our um, ATmega 328p with a 5 volts power, and we'll be using the 5 volts terminal of the Arduino Uno for that. So first, connect the 5 volts and connect it to the breadboard's 5 volt terminal, and forgive me if I don't use the proper color code. I should have a extra red jumper for the 5 volts, but I don't have one right now. So connected to the ground, and for now let's not okay, by the way, yes, let's just do it. Connect the let's also supply the for the ADC and ground. So now that we have the power supplies hooked up already, now let's have a ISP in serial programming connections going on. So again, we are doing the SPI connection, actually the SPI communication. First things first, the Arduino's pin 13, let's connect it into the ATmega's let's connect digital pin 13 to the ATmega's PB5, or serial clock. So it is located in that is located 5 pins from the bottom in the right side. So count again the right side, count from the bottom: 1 2 3 4 5. So basically it's just below the ABCC. So again, 1 2 3 4 5. Yeah. I think I might have mistaken the connections for the AVCC, so apologize for that one. Again, I'll make the correction in the schematic diagram. So the AVCC is actually 6 pins from the bottom and 7 pins for the ground. Just pull out my capacitor. There. I'm so sorry for that. And for the pin 12 of the Arduino, connect it to the MISO of the ATMEGA328P, or MISO for master in or and slave out. And for the pin 11 of Arduino is for the pin 17 or PB3. And yeah, and the last thing that we need to connect is for the reset. So that is in PB10. I mean in digital 10, pin 10 in Arduino, to the first pin in the left side. So you might skip this part. I mean I'll be providing the schematic diagram, so just follow that one there. So let me just review my connections, because I think I might have mistaken from the earlier, the connection. So just give me a minute. Everything is well. Now let's connect Arduino Uno to the PC. So let's head on to the Arduino IDE. So again, before we try to run the blink example or blink sketch, so as with the Arduino Uno, it will blink the built-in LED in the Arduino Uno, which is actually is located in digital pin 13. So in the case with the ATMEGA328P, it is actually the digital pin 13 is actually connected to the PB5, or yeah, just count 5 pins from here. So it is actually connected to the system clock. So you should be seeing it blinking simultaneously with the LED built in here in the Arduino Uno later on. So connect the anode of the LED to the PB5, and then the cathode to ground. So connect it to ground. So now that we are done, let's try to upload it, the blink example. So as you can see, our LED is blinking. I forgot to add some current limiting resistors. Let me add that. I forgot. So I have here a 380 ohm resistor. Anywhere from 300 to 500 is okay. So there, as you can see, it blinks. So even if we get rid of this SPI connections that programs the ATMEGA328P, as you can see, it's still blinking, and also the reset. But I'm still connecting the 5 volts because we need a power source. So yeah, we successfully uploaded a code to the ATMEGA328P chip, and let's see, we'll use this battery right here. Again, it is at the moment running at 5 volts terminal. So let's get rid of this 5 volts terminal from the Arduino Uno, and it should just work fine because this is a 5 volts power source. So let me just connect there. So yeah, that's good. So now let's try to get rid of these oscillators right here, these crystal oscillators, and maybe let's check, get rid of these decoupling capacitor. Although I won't recommend that one, but again, for the sake of like simplicity, and you really want to just as much as possible minimize the scale of your microcontroller, so we'll do that. But yeah, we still need this Arduino Uno again. Okay, so because we'll be configuring the bits, the registers here in the uh, ATMEGA328P chip to select its internal clock source, because as of the moment it is programmed to have a clock source, to rely on an external clock source. So we'll be configuring its register, its uh, register, specifically the lfuse or low fuse bits. So we'll be doing that one. So now let's configure our ATMEGA328P to run its internal clock source. So before we do that, make sure that you have downloaded a datasheet of the ATMEGA328P. So I have here a copy. So there's a lot of pages. So I just entered or search a keyword, the low fuse. So enter that one, and then it should redirect to this page, the page 289. So this is the bits of the low fuse byte. Um, this low fuse byte is actually just for the clock configuration. So the most significant bit talks about for the divide clock by 8, and the CK out, the clock output, the SUT. So they are 2-bit selection, the select for the startup time, and this 0 to 3 right here is what we are concerned of. This is the selection for the clock source. So basically, the value, again, it shows also here that there is a default value of these one. However, this is different from the values that is found in the Arduino Uno. Basically, the manufacturer programmed the low fuse byte to all one, so including that the selection right here. So, but again, what we are concerned of is these select clock source selection bits. So let's head on to page 26. Yeah, page 26 refers or directs to the clock source table. So again, remember that the clock source bits is comprised of 4 bits. So this is actually the different selections or options, and the default program bits on that one is pointing to this low power crystal oscillator, all one. This refers to the external clock source. So this basically ask the Atmega 328P to use an external clock source, the 16 megahertz as a clock source. And again, our concern here is to program our Atmega 328P to use its internal clock source. So this is actually the option for that, the calibrated internal RC oscillator. So this is the internal, this refers to the 8 megahertz internal clock source. So as you can see, its value is 0010. So let's go back to the table, the low fuse byte. So I'm just using the search here. So here, now that we know the value of the 8 megahertz clock source, so this 4-bit value right here should be 0010. So yeah, that's the value of the low fuse byte that we want to program. Again, we just want this upper nibble right here, the bit 7654, to use its default value to, which is 1. So which is again, it's programmed as 1. So let's just not mess that up. So 1111, and for the clock source is 0010. So remember that value because that's
the value that we want to program for the low fuse. So now you might be wondering, how do we program that one to the low fuse byte? So in order to do that, we need the help of the AVR dude. So I, I think you might be aware of this tool. This is actually the one that uploads the sketch to the Arduino board. So in behind the scenes of the Arduino IDE, whenever you upload a code, it is working on the in behind the scenes. So right here, um, right here, the AVR dude is executing some instructions, and if you don't see this in your output console, maybe you haven't enabled the verbose. So go on to preferences, file preferences. Then uh, you want to show verbose output during compilation and upload. So tick those two, compilation and upload, and click OK. Then this should show this um, lines here in the output. So again, we want to use the AVRDO to configure the low fuse byte. Um, so yeah, AVRDO offers that choice to directly configure a byte. Um, so we'll be using the command prompt for this one. So as you can see there, I have already tested this one. So just to also uh, not waste some time. So go on to your command prompt and also identify the directory of your AVR dude, which is this is usually the directory of the AVR dude if you're using Windows. So it is usually in C. So I just download my Arduino IDE at select in the disk D. So again, this is the usually the directory of your AVR dude, from the program files to the Arduino to the hardware to the tools, then to the AVR to the bin. Then you want to enter this command, the avrdude.exe, just to test out if it's really in that directory, and it should output these like help option. So um, avrdude.exe will show this help options. So now that we verified its path, we then just skip this gibberish right here. I just those are errors actually. So again, once you are in the this directory of the AVR dude, we then want to configure our low fuse byte. So first we enter the command avrdude.exe, and then the dash C. So these are actually command arguments of the AVR dude. So we want to select the path of our avrdude configuration file. So the avrdude configuration file is located at the etc. So we just step back from bin, then go back to AVR, then go to etc by doing this double period, and then the path of the path of the avrdude that conf, and then so now for the dash p. This is actually referred to the microcontroller we are using. So in this case, we are using ATMEGA328P, then space, then a dash C, lowercase c. So this refers to the name of the programmer that we want to use. So in my case, again, we are using the Arduino Uno as a programmer, and this is what they named in the Arduino ISP sketch. I don't know what's the reason why they are named this it to this one. So just copy this one, and then the dash P, capital P, it refers to the port where your Arduino is connected right now. Also, that can be easily found here or here in tools, the port where the Arduino Uno is connected. So in my case, it's connected into COM3, then dash B, lowercase b, is the baud rate. So we just set it up to 19,200 baud rate. Then here, this is the command that does, or the argument that does the magic for us. So Again, we want to configure the low fuse, so lfuse, and then colon and W for write, and then colon and the value that we want to write. Again, we decided that the value of our low fuse byte. Essentially, we just want to have the upper nibble as all one. So in hex, it's the value of hex F, and then we selected the clock source, the 8 megahertz clock source, and its value is 0010, or in hex is hex 2. So yeah, so is the value 0xf2, and M is the command for like writing an intermediary value to a certain byte. So maybe in the future video I'll be talking about the avrdude and things they can do on it. So basically, just remember that we'll be using the lowercase m, and then once you hit enter, you must you must so once you enter this command, you must expect to see this command line output. So this is basically what the AVR does to the program. It reads and writes the what we have written here, the command of the lfuse, the value of 0xf2, and if this doesn't show up, uh, maybe the Arduino hasn't been connected to your computer, or other reasons other than that. And so yeah, again, you gotta make sure that the Arduino is also connected to the ATMEGA328P via SPI, and we haven't done that because we again disconnected it from the ATMEGA 328P. So let's head on and go on to the circuit.
Once you have connected the Arduino Uno, the ATMEGA 328P, and also executed the command that I have shown you, the command prompt, it will then blink the LED. Again, the recent code that we have programmed in the ATMEGA 328P is the blink sketch or the blink example. And you might have noticed upon entering the command, it then you'll notice that the delay kind of slows down. This is because from the 16 megahertz clock oscillator, we opted to use the internal 8 megahertz clock source. So basically, the code is running half the speed of the Arduino Uno's clock. So you might have noticed that the 1000 delay in the code seems to run at 2000. That is because again we are using an 8 megahertz clock source, which is half of the Arduino Uno's usual clock source of 16 megahertz. We can actually, if you're just concerned of the delay, of course the obvious reason is to half or divide the current speed to 2. So let's say for 1000 milliseconds, you can divide it to 2, then to 500 milliseconds, and that will run essentially to act as a 1 second delay.